Hello and welcome. Today we're going to be studying two major exponent properties, the product of powers and the quotient of powers. First of all, looking at product of powers. What does 2 to the third actually mean? Well, anytime you have an exponent, that means it's times itself that many times. So remember, 2 to the third actually means 2 times 2 times 2, right? Which is 8. So x to the third must mean x times x times x, right? That's what an exponent actually means. It's that times itself. So what if we have x to the third times x to the fourth? What does that mean to do? Well, this first part really is x, right? We said that's what x to the third was. So this, really bad at those. This is really x to the third times x to the fourth, which is really 4 of these guys. That's our x to the fourth. Now what does that equal? X times itself 1, 2, 3, 4, 5, 6, 7 times. So x to the third times x to the fourth equals x to the seventh. Now, what do we do with these numbers? What could you possibly do with the 3 and the 4 to get 7? Add. Yes, this is equal to x to the 3 plus 4 power. So what we talk about, I want you to write this down, is we say when multiplying common bases, and common bases just means it's x and x, that's the base. These are the exponents, so common bases. When multiplying common bases, add the exponents. It always works, as long as the bases are the same. If one's x and one's y, it wouldn't work, but x and x are common bases, so when you're multiplying them, add them. Now, if we happen to have big numbers, like coefficients, those you would multiply like normal. For example, if I had 2x to the third times 5x to the fourth, well, we know that the x to the third times x to the fourth, those are common bases, and we add the exponents. So we know we're going to have x to the seventh. But a big 2 times a big 5 is just the same as big 2 times big 5. This is really the same thing. And 2 times 5 we know is 10. So make sure you write this down. This is called product of powers. Product means multiply, and the power is the exponent. So the product of powers, what could we summarize? What could we find as this rule if we have x to the a times x to the b? What does it equal? We just said it's going to be adding the first exponent and the second exponent. This is the product of powers rule. Make sure we know that. Okay? Next we'll look at what happens if we divide. 2 to the fifth divided by 2 to the third. Well, 2 to the fifth means 2 times 2 times 2 times 2 times 2. 2 to the third is 2 times 2 times 2. This is really what we have. Now let's think about this for a second. What is 2 to the fifth? What is this equal to? That is 32, right? And what's 2 to the third? Well, that's 8. What's 32 divided by 8? 4. So we know this answer has to be 4, but it's in 2s. So how do you make 4 out of 2s? Isn't 4 the same as 2 times 2? So we know we have to get 2 times 2. Well, we can look and see what cancels from the top and the bottom. This 2 can cancel, this 2 can cancel, this 2 can cancel. All we're left with is 2 times 2. So this equals 2 squared, which is 4. Okay? So if we have 2 to the fifth divided by 2 to the third, it's 2 squared. Okay, what if we have this? X to the eighth, 4, 5, 6, 7, 8, x, x. Cancel, cancel, cancel. What is left? 1, 2, 3, 4, 5. X to the fifth. So what do you think we do with the 8 and the 3 to get 5? Good. Subtract. When dividing common bases, these are the same, x and x, 2 and 2. The bases are the same. When dividing common bases, subtract the exponents. If there are coefficients, divide or reduce, because sometimes there's other numbers. if we had, let's say, 6 and 9, and we had x to the 4th over x to the 3rd, well, we know the x's we would subtract and get x. And the 6 and the 9, though, those are numbers. If that was easy to divide, we would just divide, but that can be just a fraction 6/9, and we know how to reduce. Divide the same thing out of the top and the bottom. Divide by 3, divide by 3. That would give me 2 and 3. So the big numbers we can divide or reduce. The exponents with common bases we subtract. So what's the rule? X to the a over x to the b equals x to the a minus b power. This is a quotient of powers, very important. When dividing common bases, subtract the exponents. Now the only thing that gets weird here is what if the denominator is bigger than the numerator? Remember, numerator is the top, denominator is the bottom. Here the x to the 5th is bigger. So what happens? Well, this is x, 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 x. Cancel, cancel, cancel. On the bottom is easy. It's x squared. On the top, people will do this and they put 0 because they think there's nothing left. But remember, if there's nothing left, there's always a number. We're just not writing it. The correct number there is always there's a 1, even if we don't write it. So if things cancel, remember that there's still a 1 there. Up here, there was a 1 also, right? 4 is the same as 4 over 1. So when this canceled, there was still a 1 in the bottom. There's always the 1, even if we don't write it. So we need to remember that. Okay, a couple examples to try. We could try these together. Try these with me. Write these down. X to the 3rd times x to the 7th. Okay, well, is this multiplying or dividing? It looks like it's multiplying, and we have common bases. So when multiplying common bases, just add the exponents. Remember, this just means x, 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 and this is another x here, and this is 7 of them. 1, 2, 3, 4, 5, 6, 7. So how many is that all together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But wait, if I go 3 plus 7, that's only 10. How come it's 11? Remember, if we don't have an exponent on it, it's not 0. There's always a 1, because there's one of them. So there's always a 1, make sure. So you could just go 3 plus 1 plus 7 is 11. Okay? Using the same logic here, it's a multiplication problem. We have common bases. We have some big numbers. This is the same as 2, I can change the order, times 3 times y to the 4th times y. I'm allowed to change the order. I think it's the commutative property that tells me that. 2 times 3, I know that's 6. And y to the 4th times y to the, what's up there? 1st, good. And we get y to the 5th. 6y to the 5th power. Here's some division. First we look at the big numbers, the coefficients. 10 divided by 5. That's an easy one, that's 2. And x to the 5th divided by x to the, oh, there's nothing there. Remember, that's always 1. 5 minus 1 power, 5 minus 1 is 4. 2x to the 4th. And here we have 18 divided by 6, which we know is 3. And y squared over y to the 8th. Uh-oh, the bottom is bigger. What happens when the denominator is bigger? That's okay. 2 of these are going to cancel with 2 of these and still leave 1, 2, 3, 4, 5, 6 left. These guys cancel. We still have y to the 6th left on the bottom. So we have 3 divided by y to the 6th. Okay, now, here are 3 problems I want you to try. So I want you to stop the video here. I want you to work them out for yourself. There's a little bit more complicated. And I want you to pause. Right now, ready? Everybody, pause. Did you pause? Work it out. Okay, good. Now you're done. Check your answers. I can make it work. See if you got them right. If you got them right, you are finished. Only one last thing to do is write a question of your own at the end. Anything you want. Something that you think maybe somebody will get wrong, maybe a complicated one like this, or something I didn't explain very well that you honestly have a question about that you want to ask about. Write your question, and you're finished. If you got these wrong, we will see the help video. Check the help video of product of powers. See ya.